All right, welcome to Chem with Com, and we are continuing our polyatomic ion and nomenclature lecture. This is part 3. This is going to be nomenclature of ionic compounds and acids. All right, so let's get going. So we talked about polyatomic ions many different times, but this is, I want to point out some very specific things here. The important ones for nomenclature in this chapter end in ate, ate, or ite. So let's look at the ites. Nitrite, phosphite, sulfite, hydrogen sulfite, chlorite, hypochlorite, right? And these aren't exhaustive, right? There's many other polyatomic ions. We just aren't going to list all of them. And that ends in ite, as you can see, nitrite, right? And we also have elements that end in ate, acetate, carbonate, bicarbonate, nitrate, sulfate, hydrogen sulfate, phosphate, hydrogen phosphate, dihydrogen phosphate, perchlorate, chlorate, chromate, dichromate, permanganate. Right? And so again, a lot of polyatomic ions for this chapter and this section. I want you to definitely pay attention to the endings, the ate or it. I did add phosphite to the list because we use that quite often, and acetate. I rewrote the formula how we usually see it. This is a kind of a different way to write it, but we usually write it as a C2H3O21 minus. All right. And also, again, we have positive charges, we have negative charges, we have multiple negative charges. It's a 2 minus, 3 minus, 1 minus, right? So a lot of little details, but make sure you're comfortable with this chart. All right, how to name things. Here we go. So this is a continuation of our covalent or molecular compounds or covalent compounds. You want to have your periodic table handy that tells you which elements are metals and nonmetals, and which elements have fixed charges, and what those charges are. Remember, and whatever you don't have listed, those are going to be variably charged. Have your polyatomic ion table handy, preferably the one you created, right? And maybe point out the eights and the ites. And then next, you're going to start in the upper left-hand side where it says start here and follow the arrows appropriately. Okay, so we're just going to do this one real quick. And then since we did it last lecture, but let's just do it real fast. All right, so we're going to start here. Let's write our molecule here, PF5. Ask these questions. Does the molecule have metals? No. Polyatomic ions? No. H on the left of the word acid? No. We're going to go here. We're going to do the first prefix, first element, second prefix, second element, and then change the ending to IDE. So this is going to be mono phosphorus, and then we have 5, so it's going to be, so 1 was mono, 5 is penta fluoride, right? But look at the second thing. Leave out the prefix mono for the first element if there's only one of those atoms, right? And there is, so we're not going to include the word mono on this one. We're just going to call PF5 phosphorus pentafluoride, right? Again, this is S sulfur. We leave out the mono. Hexa, because it's 6F fluoride. Dinitrogen, because there's 2 nitrogens, so that's di, right? Nitrogen, dinitrogen, right? We'll change the pen up a little bit because there's a 1, so that's going to be mon. Oops, let's do that. Keep it consistent with the labeling. And then we have ox for oxygen. And then ide, dinitrogen monoxide. All right, cool. So let's do another one. start over. Let's get us a new little setup here. Let's try this. N, let's do it in red maybe. NaCl. Okay, does the molecule have metals? Yes. No polyatomic ions, no H on the left of the word acid. But since we answered yes, we're going to move down here. And there are metals. Yep. Polyatomic ions, no. H on the left of the word acid. Yep. So let's continue down because we have metals in here. All right. So let's move. So I'm just going to rewrite the molecule here so we can pay attention. All right. So now let's move here. Does the molecule have metals? Yes. So instantly when we see the yes, we're going to go to the right here. It's going to change my pen color because it's going to match up pretty good. All right. So let's actually rewrite this in blue so that we stay on track. All right. Yes. Okay. Is sodium a fixed charge metal? Yes. How do I know that? Well, you go up to your periodic table. That's where it was. It's way up here, right? Sodium is a fixed charge metal. It's always going to be 1 plus. All right. So that's why we know it's fixed charge, right? All right. So then when it's fixed charge, you just put the name of the metal and then followed by the name of the nonmetal, and you change it to ide. So this is going to be sodium chloride. All right. Same with silver nitride. And again, I'm going to reiterate and emphasize silver is a fixed charge metal. Remember this silver here that I said to remember? Silver is a fixed charge. So we're going to do the same thing here. Silver and then NiT for nitrogen, NiTr, nitrogen, nitride, right? So again, if it's a fixed charge metal, you're going to just name the metal, name the nonmetal, change the ending to IDE. Okay, those are the kind of two of the easier ones. Now we're going to get a little harder, not by much, but enough that it's noticeable. All right, so let's start over. Let's do another molecule. Let's do this one in green. All right, let's do something like Fe2O3. All right. So does it have a metal? Yes. So immediately we can go here and we go over here. All right, so I was doing it in red. My bad. Follow the little pattern here. Fe2O3. And we're going to say yes, and then yes. All right. But this is now a variably charged metal because we'll say Fe, right? And let's go up to our table. So there's no Fe. So that means it's variably charged. Variably meaning it can have more than one charge, or it can have different charges, right? All right, so let's go back to our stuff here and let's take a look. So they're saying that it's iron 3 oxide. Let's take a look here. Name of the metal, iron. The charge in parentheses, we don't know. And the name of the nonmetal with the ending changed to IDE. And that's O, so it's oxide. But how do we get the charge? Let's figure this out. Okay, here we have 3 oxygens for sure. 1, 2, and 3. Here we have 2 irons. We're going to try and make a neutral compound. right? And we did this a couple of lectures ago, 2 lectures ago. So if you're having difficulty with this, go back 2 lectures and you'll figure this out. Okay, we know that oxygen is always 2 minus because oxygen is a fixed charge ion. So here we have a total of a 6 minus, right? To make a neutral compound, we need 0 to add up to 0. So here we have a 6 plus, right? So since we have 2 irons, we have to have a 3 plus on each of them, right? 3 plus plus 3 plus is 6 plus. 2 minus 2 minus 2 minus is 6 minus. That makes 0. So because this is a 3, that's now iron 3 oxide. All right, let's do this one. Let's do tin. Tin is variably charged. We know we have 1 tin and we have 2 oxygens because of the formula, right? 2 here, there's nothing here, so it's a 1. Each oxygen is a 2 minus. We want to make neutral compounds, so we have to have a 2 plus. Because there's only 1 tin, all of those positive charges have to go to that 1 tin. Oh, sorry. I misspoke on all that. 2 minus and 2 minus is 4 minus. So we have to have a 4 plus. So that means this tin has to be 4 plus. So that's why this is called tin 4 oxide. All right, last one here. Let's do a polyatomic. So let's erase this and start over. All right, if it's a polyatomic ion, and let's say NH4Br, right? Does the molecule have metals? No. Polyatomic ion without an H? Yes. So we're going to go here and we're going to figure out, hey, it's a polyatomic ion. So we're going to come down here in this list and we're going to name ionic compounds with a polyatomic ion. You're just going to basically read the name of the cation, which is the polyatomic ion in this one. Ammonium, right? This is ammonium. And then Br is bromine, but we're going to change it to IDE. So ammonium bromide. Now, if the anion is negatively charged, we're not going to change the ending. So we don't change it to IDE. This is just called ammonium phosphate, right? Not going to change the ending, okay? So if the anion is negative, you don't change the ending. If the anion is a monoatomic ion, you're going to change it to IDE, like ammonium bromide or ammonium oxide or ammonium fluoride or ammonium nitride, right? We're not going to change, we're always going to change the name to IDE if it's monoatomic, 1 atom. All right. All right, so we named a bunch of stuff already. Let's continue and let's do a different one then. Okay, let's say we had something like, do a quick preview. Let's do green. All right, green, something like HCl. Does the molecule have metals? No. Polyatomic ion? No. So we're going to go down. Does H on the left or the word acid? Yes. Right, so then we go down here. All right, H on the left of the word acid. Yep, basically, if you say no here, you messed up. Go back to the first slide on nomenclature and just kind of cycle through and see where you end up, right? But since I'm going to rewrite this here, HCl, boom. Is there oxygen in the acid? No. So you just say the word hydro, the name of the non-H atom or molecule, with the ending changed to something ic acid. So hydro, chlorine, so we say chlor, ic acid. All right. All right, so let's say we had something like, and we could do hydrofluoric, HF, hydrobromic, hydroiodic acid. We also have, let's do this one. H, hydro, so this is going to be hydro. And then what's a CN? You might not be familiar with this because you're kind of new to this, but CN is cyanide. So let's remember that, cyanide, right? So cyanide, right? Cyan, ic acid, hydrocyanic acid, right? So cool. We have an acid, and the key is it does not have an oxygen. No oxygen, right? If there's no oxygen, you do that top part. If there is an oxygen, we do the bottom part. Let's do that next. Okay. Let's do this, and I think we have it on purple, right? Let's do something like H2CO3. All right, H on the left, yes. Let's go here. Is there an oxygen in the acid? Yes, there is, because it's the H2CO3. Let me do an arrow from the opposite way, just to show you. Yeah, right, that oxygen. So we're going to identify the polyatomic ion and see if it ends in an ate or ite. Remove all H's, and whatever is left is a polyatomic ion. So let's do this. We have H2CO3. We're going to remove all the H's. So there's one H and two H, and then we have CO3. All right. We know that H's are always 1 plus. Let's go back to our table and show you. So H's are always 1 plus. So we're going to have to put 1 pluses on there because there's two of them. All right, so now that we know that each hydrogen is a 1 plus, and we have two of them, that gives all the hydrogens a 2 plus, right? Total, it's 2 plus. So that means this one is going to be a 2 minus because this is a neutral compound, right? So now let's look for CO3 2 minus. On our polyatomic ion table. CO3 2 minus, where are you? Are you even here? Here you go. So carbonate. All right, carbonate. Let's take a look. So this is carbonate. All right, it's carbonate. So identify, okay, if the ending is in 8, you're going to say the base name of the ion, carbon, and change it to IC, carbonic acid. Right, again, identify the polyatomic ion in the acid, see if it ends in 8 or 8, remove all the H's, and whatever is left is the polyatomic ion. This polyatomic ion was called carbonate. Because it ends in 8, we're going to change it to ic. So carbonic acid. All right, let's try another one. I'm gonna, let's see here, just scrap a little bit of this. Let's start over. All right, let's do something like HClO2. Okay, is there an H on the left of the word acid? Yes, right? HClO2. And since there's an oxygen, it's yeah. All right, so let's separate these two. That's going to be HClO2. We're going to break apart the H. We know each H is 1 plus. And we have a what's called a ClO2 polyatomic ion. Since there's a 1 plus, we have to have a 1 minus. So let's look for this. ClO2 1 minus. ClO2 1 minus. That's chlorite with an ITE. All right, so this is chlorite with the ITE. Well, if it ends in ITE, we're going to say the base name, which is chlor, change the ending to OUS acid, chlorous acid. So if it ends in 8, you're going to change it to ite. Sorry, 8, you're going to change it to ic. If it's ite, you're going to change it to OUS, right? And sometimes the base names are weird and don't exactly follow the rules, like H2SO4, right? Since there's an oxygen, we look at the polyatomic ion. That should be sulfate. So I'm not going to put the parentheses around it. That's sometimes confusing. So let me just box it so you can see what I'm talking about. Sulfate. So it should be sulfic acid, but it's actually sulfuric acid. PO3 should be phosphite, so it should be phosphorus acid, but it's actually phosphorus acid. There's a few that the names are slightly different than the rules, but they're very, very close, right? We talked about this already. If the acid is written as a gas, like with the G at the end, then it's not an acid because we cannot donate the hydrogen to water because there is no water. And it would just be named as a molecular compound. So this would be a molecular compound or covalent compound. You just name it hydrogen and chlor followed by the IDE. We won't have a ton of this, but this comes up in other classes. I wanted to just introduce you to the topic. All right, let's do some other situations. This is a little easier. Name of ionic compound, you just put the prefix in the word hydrate. So this is magnesium sulfate. I'm going to underline that, magnesium sulfate. Hepta, because there are 7, and then hydrate. Sodium carbonate. Deca, because deca is 10. Right, deca's oh, sorry, I left off deca. 10 equals deca. If you go back, it will tell you the other ones. Deca hydrate. All right. All right, so that's basically it for the hydrates. You just say the name, the prefix of how many waters there are, and then the word hydrate. So magnesium sulfate, heptahydrate, sodium carbonate, decahydrate. You have copper sulfate. I think it's heptahydrate. So yeah. All right, so now let's do some stuff. Right, we did this one already. So let's move on to this one. FeO. Again, how to figure out the formulas? We need to make neutral compounds. Neutral compounds. Use the information that we know. We know oxygen is always going to be a 2 minus. Iron, we don't know, right? Because it's a variably charged ion. We'll say variably charged. So because it's variably charged, it might be +2, +3, +4, +5, +6. We don't know. But since we know 2 minus, right? And the total charges, this is a 2 minus, they have to add up to 0. So we know that we have to have a 2 plus and a 2 minus to add up to 0. So this becomes iron 2 plus. So this is called iron 2 oxide. All right, same with this one. Lead, variably charged. Right? But we know fluorine. Let's check this one out. F. Let me see if this works fine right here. So F, 1 minus, 1 minus. We have a total of 2 minus. PB, we only have one of them. But we need a neutral compound. Neutral compounds. So here we have to have a 2 plus charge to make a neutral compound. And then since we only have one atom, all of those charges have to go to lead. So this is going to be lead 2 fluoride. And change that last part. Let's do this other one. I'm going to bring this out over here so it's easier to see. F, 1 minus, F, 1 minus, F, 1 minus, F, 1 minus. That means we have a 4 minus. Well, we have to make neutral compounds. We only have one single lead. So that lead has to carry all of those 4 positive charges. So this is going to be lead 4 plus. So this would be called lead 4, it's IV, fluoride. Right? Lead 4 fluoride. All right. Let's do some other stuff. Make neutral compounds. Okay, cool. Sulfurous acid, since the acid ends in OUS, right? OUS, that ends up being ITE. So this is the acid. This is the polyatomic ion, which is SO3 2 minus. Each hydrogen is a 1 plus, right? So boom, sulfurous. That means we have 3, right? 2 minus. We know each hydrogen, right? This totals a 2 minus charge. We're trying to make a neutral compound again. So each hydrogen is a 1 plus. So how many hydrogens do we need to make a neutral compound? Well, we need 2, right? Then that makes a 2 positive. So that's going to be H2SO3. All right, let's do phosphoric acid, right? So ite, ick, right? They're saying ite if it's an acid, ick if it's, oh, sorry, I got that mixed up. Ick is the acid. Phosphoric acid is a polyatomic ion. Let's look for this. Phosphoric acid. So if it's phosphoric, it's probably something like phosphate, right? Ick to 8, ick 8, ick 8. Oh, sorry, ick 8. Sorry about that. This should be ick and 8. And if you get confused, because I just confuse you, you go up here and you look here, right? Ick and 8, right? And let's go back up. So we're looking for phosphate. You're going to look at phosphate. Where's phosphate? Phosphate. Boom. Phosphate. This is the formula. PO4 3 minus. So phosphate equals PO4 3 minus. But how many hydrogens do we have? Well, let's check it out. PO4 3 minus. So we have a 3 minus charge. We have to add something to that to get to 0. we know we have to have a 3 plus, because 3 plus and 3 minus equals 0. Each hydrogen is a 1 plus. So how many hydrogens do we need to make a 3 plus? Well, we need 3 of them. So that becomes 3 hydrogens, so H3 and 1 phosphate, PO4. All right, I'm going to go a little faster now, right? OUS becomes ITE, right? So nitrous acid is nitrite. Let's look for nitrite. Nitrite. That's NO2 1 minus. Oop. This is NO2 1 minus. We have to have just one hydrogen because it's a 1 plus, so that becomes HNO2. All right, acetic, right? Ic is 8, so acetate, because we know it ends in ic. So let's look for acetate. This one, that little new one I put, C2H3O2 1 minus. C2H3O2 1 minus. We know we need to have a hydrogen because there's a 1 plus, so that's going to be HC2H3O2. All right, let's continue. We're basically just solving problems at this point. Name for this compound, this is a fixed charge. So this is going to be called magnesium chloride. All right, this is a variable charge. Oops, sorry. Variable charge. So we don't know, but we know chlorine, and there's 2 of them, is a 1 minus. So we have a 2 minus total. That has to add up to 0, right? We only have 1 copper. We need here a 2 plus, so we know this is 2 plus. So this is copper 2 chloride. All right, this is 2 polyatomic ions, so it just would be called ammonium carbonate. So we're basically just looking this up. And actually, this is a wrong one. It should be actually NH4, because if you look at the charges, NH4 is a 1 plus. CO3 is a 2 minus, right? So we need 2 of these. Okay, so NH4, we have a 2, and this is CO3. So that's ammonium carbonate, but this is the actual formula, NH4 subscript 2, CO3. All right, ammonium sulfate, NH4 1 plus. Sulfate is SO4 2 minus. All right, so we can do crisscross applesauce, or you could figure out how many charges you need, but this is going to be similar. NH4 with a subscript 2, and then you have sulfate, which is SO4. I'm going to start circling these so we can see ammonium carbonate, copper 2 chloride, and then this is magnesium chloride. All right, name for this compound, NaHSO4. Let's figure that out. Well, we know this is sodium. When you break this apart, we know sodium is a 1 plus, right? It becomes Na1 plus HSO4. Let's find that. And we know that when the sodium comes off, this has to be a 1 minus because when you combine them, they make a neutral compound. But let's go for HSO4 1 minus if it's up here. HSO4 1, boom, hydrogen sulfate. Another word for this is called bisulfate, but let's not get complicated. We're just going to call this sodium hydrogen sulfate. All right, H on the left, acid. There's two of them, 1 plus, H1 plus. This is Cr2O7. Has to have two minus charges. Let's try to find Cr2O7 2 minus. Well, here it is. Dichromate. Cr2O7 2 minus. So let's look at the dichromate. Oops, sorry. Dichromate, but we're going to change that to ic. All right, so it's going to be dichromic acid. Remember, the polyatomic ion is the key. Find out ate and ite, change it appropriately. What's the name for this compound? Pay attention to that G, right? Normally, if it was an acid, it would be hydrochloric. But since it's not, it's just hydrogen chloride. All right. Well, it's a lot of practice problems. Hopefully that gets you through, and you can use these to find other ones. But yeah. All right. Thank you for watching, and good luck, and I'll catch you later. Thank you.